Welcome to my YouTube channel. Before going to start the video, please do subscribe and keep supporting. So in this video, the learning outcomes are state the physical factors that affect the value of resistor and calculate the resistance value by using the color coding. And second topic is compare the features of carbon and wirewood potentiometer. Third point is describe the working of rheostat and mention its applications. Fourth topic is define the temperature coefficient of the resistance and explain the effects of temperature on resistance. First topic is physical factors that affect the value of resistor. Means there are some physical factors that affecting the value of the resistor. In that physical factors, first factor is length. This length of the material will affect the value of the resistor. Means if the length of the material is longer, then the resistance also high. Means length and the resistance will be directly proportional. And second point is cross-sectional area. So cross-sectional area is also one of the physical factor that affecting the value of the resistor. And these cross-sectional area and resistance are inversely proportional. Means cross-sectional area of the material is longer, then resistance is less. If the cross-section area is less, then the resistance is more. And third point is temperature. So if a material having the high temperature, then the resistance also high. Means temperature also we consider as the temperature and resistance will be directly proportional. And final point is fourth point, kind of the material. And means different types of material having the different resistivity. Means iron has some resistivity and copper has some resistivity. So based upon the resistivity of the material, the resistance will be changed. So these are the physical factors that affecting the value of the resistor. Now we'll see the resistance value, how to find out the resistance value by using the color coding. So there are different types of methods to find out the resistance value. And this one of the method means color coding is one of the method to find out the value of the resistance. So when we observe a resistor, on the resistor, there are different types of colors are printed. So based upon that colors only, we are going to find the resistance value of that particular resistor. For example, on resistor, a black color is printed means the black color value is 0. If brown is there means brown color value is 1. Like that, there are the different types of colors and each color they assign one particular value. Based upon these values only, we are find out that there is some difficulty to remember all these colors, right? So to remember all these colors in a sequence, there is one short trick to remember all these colors in order. The short trick is BB Roy, Great Britain, very good wife. Means here B for black, second B for brown, R for red, O for orange, Y for yellow. In great, the G stands for green. And in Britain, B for blue, V for violet, Z for grey, and W for white. So this is one short trick to remember all these colors. Now we'll see the one example. In this slide, we are observing a resistor, right? So our target is to find out the resistance of a particular resistor. How we are going to find out the resistance of this particular resistor means I already told that there is some colors are printed on the resistor. Based upon that resistor, based upon that colors only, we are going to find out the resistance. If we observe this resistor, there are four colors on this resistor, right? So if a resistor having the 4 colors means that resistor belongs to the 4 color band. If a resistor having the 5 types of colors, and that belongs to the 5 color band. But in this resistor there are 4 colors. So this is belongs to the 4 color band. So we already know that what are the values of the particular colors. So when we see this brown, we know that brown is 1 and black value is 0 and red value is 2 and here gold. So gold is the torus, means a color which is on the right side, that is the tolerance. In the color coding table, there are the tolerance for every particular color. So gold color tolerance is plus 5%. And here 1 for brown, 0 for black into 10 to the power of 2. Here why we are given 10 to the power of 2 meal. When we see the diagram before tolerance, there is some values that is multiply. So multiplying is here Red color has 2 means 10 to the power of 2. That's why we are assigning red is 10 to the power of 2. When we multiply these n into 10 to the power of 2, we get 1000. Means 1k ohm. Means the resistance of this particular resistor is 1000. We also said that 10k ohm. This is the process how we are going to find out the resistance value. Let's say another example for find out in the resistance value. See this diagram, there are the 5 colors on this resistor. Means it belongs to the 5 color band. So we know the values of these particular colors, and the brown which is presenting on the right side of the resistor means that is the tolerance. We know the tolerance of that resistor, that color is plus or minus 1%. So we know the tolerance, and now we have to find out the resistance value. So we know that red is 2 and another is 2, black is 0, orange is 3, brown is 1. See here, orange is the last color, right? So what is the value of orange is 3. Means we have to multiply with 1000. Means 10 to the power of 3 means 1000. So 2 to 0 into 1000. So now we got the 22,000. Means this resistance value is 220 kilo ohms and 1% of tolerance, right? So this is the way how to find out the resistance value by using the color coding. So it is very simple. Just we have to know the values of that particular colors and what is the color presenting in the loss, that we have to multiply with that digits. So our next topic is compare the features of carbon and wirewood potentiometer. So before going to compare the features of carbon and wirewood potentiometer, we need to know about the carbon composition resistor and wirewood potentiometer, right? So first we see different compare the features of both. The first, carbon composition resistor. A carbon composition resistor means this resistor is the oldest one which is used in electronics. And in this resistor, they are using the carbon mixture. So by using the carbon, the resistor will be made. That's why the name it is called carbon composition resistor. And the resistance value is depending upon the amount of copper mixture. So if mixture of carbon is less means the resistance will be less. If the carbon mixture is more, then the resistance will be more. That's why. So the resistance value is depending upon the amount of copper mixture. And these carbon composition resistors are mainly used in the old radios, TVs and power supply. And the tolerance of these carbon from the 5%, 20%. And this is the internal structure, means how the carbon composition resistor presenting inside. And now wirewood potentiometer. So this wirewood potentiometer is a type of the variable resistor. Means this wirewood potentiometer is made up of by using the nickel material, means resistive wire. So this is about the wirewood potentiometer. Now we will see the features of carbon composition resistor and wirewood potentiometer. So these are the features of carbon and wirewood potentiometers. First features, material, means which material is used to make this carbon composition and wirewood potentiometer. Means carbon film is used in the carbon composition resistor and resistance wire. Means nichrome is used in the wirewood potentiometer. And second point, for handling, so it will carbon composition will handle with a low power application. And coming to wirewood potentiometer, the wirewood potentiometer can handle with the high power applications. Third point is accuracy. So carbon composition has less accuracy and wirewood potentiometer has the high accuracy. I mean fourth point, durability. So how long it will be maintained means carbon composition will be moderate and wirewood potentiometer will be high. Fifth point is noise while adjusting, means while we are going to adjusting the carbon composition resistor or wirewood potentiometer is how noise will be, it will generate. Means while adjusting the carbon composition resistor, it will make more noise, and coming to wirewood potentiometer, it will generate the less noise. And temperature stability. Temperature stability means how long it has capability to work on the temperature. Means carbon composition resistor will put to moderate and wirewood potentiometer is good, means it has good temperature stability. And what are the applications? Means where this carbon composition and the wirewood potentiometer is applicable. So mainly the carbon composition resistors are mainly used in the audio equipment and the power circuits. low power circuits. And coming to wirewood potentiometer. So these wirewood potentiometer is mainly used in the industrial equipment or power control applications. So these are the features of the carbon and wirewood potentiometers. Our next topic is working of rheostat. Rheostat is nothing but the variable resistor. Means when we classify the resistors are classified into two types, right? One is fixed and the second is variable. Fixed resistors means fixed resistors are not able to change the values of resistance. But in the variable resistor means this rheostat. So by using this rheostat, we can adjust the current by adjusting the resistance in a circuit. Rheostat is the electrical device which is used to adjust the resistance in a circuit. Now we'll see the construction, and first image is the real image, and these are the parts names which is mentioned side of the real image. So basically in rheostat there are three terminals A, B and C, but we are using only two terminals, that is terminal A and the sliding contact. This sliding contact is also called as the pepper. Means this rheostat will works on the principle of the Ohm's law. So we already know about the Ohm's law, right? So when we increase in the resistance, the current will be decreases. In rheostat, how the resistance will be increased means by using the sliding contact. Sliding contact means that vapor. So by using that device, we are going to increase or decrease the resistance value. Based upon the increasing or decreasing, the current will be adjusted. If we increase the resistance means the current will be decreased. If we decrease the resistance means the current will be increased. And one main point here we have to note it down is, so if we use all three terminals which is presenting in the rheostat, that will act as the potentiometer. This potentiometer which is used as the voltage divider. So if we use two terminals which is presenting in the rheostat, that will work as the rheostat, and it will use as the current adjusting by adjusting the resistance. These are the applications of the rheostat. First point is lighting systems. In lighting systems, the rheostat is used as the brightness control device. And second point is fans and the motors. In fans and motors, this rheostat is used as the speed control device. And third point is electric heaters. In electric heaters, it is used as the temperature control device. And in fourth point is audio equipment. In audio equipment, it is used as the volume adjustment device. In fifth point, industrial equipment. In industrial equipment, this rheostat will work as the motor speed. It is used to control the speed of the motor. Like in this way, rheostat is used in the various applications. Our last topic is temperature coefficient of the resistance. So this temperature coefficient of the resistance is defined as, so for example, there is one original resistance. So when the temperature of the is changed, according to temperature changes, the resistance will be changed. That is known as the temperature coefficient of the resistance. Means it is defined as the change in resistance per unit original resistance per changing in the temperature is known as the temperature coefficient of the resistance. To find out this resistance, there is a formula, that is alpha is equal to RT minus R naught by R naught into T minus T naught. Here alpha, it is the temperature coefficient of the resistance. RT is equal to resistance at temperature. R naught is the reference temperature, and RT to R naught, it is the changes in the temperature. So this is the temperature coefficient of the resistance. Thank you very much for seeing this video until end, and don't forget to do subscribe and keep supporting.